So next one is a gradient of a scalar. It is defined as the maximum rate of change of the scalar quantity with respect to space coordinates. So it is a maximum rate of change of scalar quantity with respect to space coordinate, denoted by del. So in general, delta is defined 1 over h1 dou by dou b1 ab1 and 1 by h2 dou by dou b2 ab2 and 1 by h3 dou by dou p3 ab3. So you memorize this one. We have the first coordinate is the Cartesian system where the h1 h2 h3 values are 1, p1 p2 p3 are x y and z. So substituting these h1 h2 h3 values in the equation 1, you will have the del operator. You have the del operator series dou by dou x, that is for this p1 you substitute x, for this p2 you substitute y, for this p3 substitute z. Substituting the values of p1 p2 p3, you have the del operator for Cartesian system. Similarly, for cylindrical system, h1 value is 1, h2 is r, h3 is 1, p1 p2 p3 are r by z. So substituting this h1 h2 h3 values and p1 p2 p3 values in the equation 1, you have the del operator values this is the gradient of cylindrical coordinate system. And the last one is spherical coordinate system. h1 value is 1, h2 values r, h3 values r sin theta. So p1 is equal to r, p2 is equal to theta, p3 is equal to pi. So substituting these values in equation 1, you have del operator for spherical coordinate system. That is for p1, for this p1 you substitute r, for this p2 you substitute theta, for this p3 you substitute pi, for this h3 you substitute r sin theta, h3 is equal to r sin theta you substitute. So so this is the del formula for all the coordinate systems. Again, back to the definition. It is defined as the maximum rate of change of the scalar quantity with respect to space. So when we see Cartesian coordinate system, x y z are the space coordinates value. So rate of change of it is a rate of change of any scalar. Suppose you take a scalar v, the corresponding scalar value v, here v. So this is a scalar value. This is defined as potential gradient. Its potential is varied with respect to space coordinates x y z. So similarly for all the coordinates, we can find the gradient value for any scalar quantity.